like currently we're doing chemical bonding in the Allen, and basically in chemical bonding, basically the chemistry teacher is explaining all the concepts in chemical bonding very well, like whisper theory, VBT theory, molecular orbital theory, hybridization, or all the
Uh,
concepts. Well, the chemistry faculty is able to explain in the Allen, sir.
okay, okay, perfect, perfect. So now today we'll start our class with the orbit and orbital. So put a heading: orbit and orbital. Orbit and orbital. Now, what is orbit? So we know that K shell, L shell, these are all the orbits, which is the definite circular part of a path around the nucleus. Now, this thing is basically it's denied by the Heisenberg uncertainty principle because we learned that it is not possible to find the position and velocity, and electrons are always revolving around it. So the position of the electron is not we are not able to find it out. So, with that note, he says that there will be the maximum probability which is defined by the orbital. Are you getting this?
Yes, sir.
Orbitals are like they came after the Heisenberg uncertainty principle. Are you getting this point? Say yes or
So
no.
basically, Heisenberg himself invented the word orbital.
No, it's not necessary though. But that is not given. Like I can't say that he only give the orbital, but we can understand it like this: that orbital defined as the maximum probability of a electron present in that path, and orbit says us that it's a definite circular path. So now we are working on the orbital. Now in the 11th class, it's not a orbit, but it will be orbital that we are working. Are you getting this point? No.
Yes, sir. Yes, sir. Got it, sir. So
Okay.
like orbital basically is like it includes s orbital, p orbital, d orbital, and f orbital. Like it
Yeah.
includes basically the subcells. Basically the
Subcells. Subcells. Perfect. Perfect. So now write it down.
orbital.
Okay. So you have to make in tabular form. Okay. Yesterday, which we discussed. No. Write it down. Orbit. It is a well-defined circular path around nucleus.
Hmm. 1 minute. I have to draw
It
the.
is a well. Okay. Okay. Quickly. Okay. Done. Now below orbit, write it down. It is a well-defined circular path around the nucleus. It is a well-defined circular path around the nucleus.
Yes, sir.
Okay. In which, after that line, write it down. In which electron revolve. In which electron revolve. Then in orbital, first point is it is a 3D space except S cell. It's a
What?
3D. I guess S is also 3D, no? Just give me a second. Yeah. It is a three-dimensional space around nucleus except s orbital except s orbital.
Because S is 2D, right?
Yeah, s is 2, which around the nucleus within which the probability of electron is maximum, within which the probability of electron is maximum. Now write it down.
Wait, sir. I'm doing it, sir. Done, sir.
Hmm. Now write it down. Okay, write it down. The concept of orbit does not depend on wave character of electron and uncertainty principle. The concept of orbit does not consider the wave character of electrons and uncertainty principle.
Does not?
Does not consider the wave character of electrons and uncertainty principle. While the orbital,
Wait, wait, wait. Done, sir.
while the orbital is in accordance with the wave character as well as uncertainty principle.
The, the orbital is?
Orbital is in accordance means orbital have like orbital is based upon the wave character as well as the uncertainty principle.
The orbital is in accordance?
Is in accordance uh, with the wave character of electrons as well as uncertainty principle. Understood?
Yes, sir.
Now next
Wait, I'm doing
next is
done, sir.
now next is that maximum number of electron in orbit is defined by 2n square. Maximum number of orbits is defined by 2n square. Maximum number of electron in an orbit is defined by 2n square.
Done, sir.
Then write it down. Maximum number of electrons that can be occupied by an orbital inside this subshell is always 2.
Maximum number of.
Is
Number of electrons.
that can be occupied by an orbital is always 2. Okay, understand it like this. See, for example, Mama says that Edric, in the Almira, there is a cache.
Yes.
Okay, so now you will go and you know that in the Almira there is a cache.
Yes. Yes.
But inside the Almira, there is another drawer is there, and another drawer has another lock in that. That when you will open it, then only you will get the cache. So the Almira considered as a S subshell, P subshell, D subshell, F subshell. Okay. Now inside the like S subshell has 2 electrons. That is called as orbital. Like P has 3 orbitals. We will learn in the now wave function of that. So what we are trying to say that here now the value is dependent upon the orbital. Okay, orbital says that maximum number like the drawer inside the Almira is the proper place of a cache. No, are you
Yes.
getting my point?
Yes,
So
sir.
in the same way that orbital in the S shell or the P shell or D shell, they are the maximum number of electrons that can be possible present inside them.
Okay. So like the number of orbitals in the S subshell, P subshell, D subshell, and F subshell
Yeah. So
is not
that orbital says us the electrons are there.
like
Got
the
it?
orbital only will say that the electron is there, not the orbit. The orbital.
Orbital, which is the maximum number of probability that electron can be there in that.
Yes, sir.
Okay, now write it down. Wave mechanical model of atom. Next heading, wave mechanical order of a atom. Now write it down.
Wait, sir. Done, sir.
Okay. Write it down.
Yes, sir.
What is I'm saying? Yeah. It was proposed by Schrodinger. Schrodinger.
Schrodinger. Schrodinger.
Schrodinger. Yeah, well, that's the same person. Schrodinger. In 1926,
It was explained by Schrodinger.
Schrodinger. In 1926, according to this, according to this,
Wait. Okay. So this
the motion of electrons,
the motion of electron.
the motion of the electron inside an atom, the motion of electron
Yes.
inside the atom is described in terms of mathematical function, is described in terms of mathematical function name as wave function, name as wave function, name as wave function. So do you know that equation?
Yes, sir. I know the entire equation, sir.
What is that?
Okay, so it will be dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m upon h square into e minus v into psi is equals to 0.
Ah,
That psi
perfect,
is
perfect.
that psi is the wave function. That psi is the wave
Yeah,
function.
psi is the wave function and psi square is the,
Density.
yeah, probability, means basically probability of finding an electron.
Yeah.
So psi is basically the position of that particle and psi square is the density, or we can say the probability of finding an electron. Okay, so we'll not write that equation because it's not there in your book, but we will write it down like this, that psi is the function of the position of particle and psi square is the probability of finding an electron. Got it? No.
Yes. Yes, sir.
Write down.
What's that?
Write it down, this thing. Psi is the function of position of particle and psi square is the probability of finding it. Now, based on the Schrodinger, this theory, wave mechanical model of atom, we got some important aspects. And the first three quantum number that we got is principal quantum number, then azimuthal quantum number, and magnetic quantum number. Okay, and these quantum number helps us to describe that 3D region of a orbital. Are you getting this?
Yes.
Means these three quantum number helps us to decide the probability of finding an electron. Are you getting this?
Yes, sir.
No. So write it down, this
Like
thing.
any relation between psi and this thing.
Yeah.
Psi.
So we, so write it down. On solving Schrodinger
Mhm.
wave equation for hydrogen atom, on solving Schrodinger wave equation for hydrogen atom, we get a number of wave function. We get a number of wave function, means number of place where the electron is maybe not maybe present,
We get a number of
and
wave functions.
yeah, number of wave function. Now write it down. They include three quantum numbers. They include three quantum numbers.
Sir, you're
First
going
is
too fast.
Prince.
You're going too fast.
Oh, sorry.
Mm.
First is principal quantum number. Second one is azimuthal quantum number. And the third one is magnetic quantum number. Okay, understood? So now write it down. Write it down. These quantum number helps.
Ah, wait.
Okay. Then I will explain each quantum number to you. Okay.
Yes, sir.
Are you getting this? No.
Yes, sir, I am, sir.
Okay. Like, like the teaching which I am giving, is it helping you now?
Yes, sir, it is. It is.
Okay.
Like, it has helped me a lot, sir.
Okay. Then perfect. Okay. Now write it down. These quantum number done.
Yes.
These quantum number help in to describe shape, shape, and probability of finding electron. Shape of orbital and probability of finding an electron. So means it will give us shape of the orbital also with the help of this principal quantum number. It will give the shape of the orbital also, as well as it will give the probability of finding an electron. Like where is the maximum probability of finding an electron? Are you getting this? No.
Okay. So like so first the wave function, the psi, that
Hmm.
psi will give three quantum numbers, and these three quantum numbers will give you the shape of the orbital and the probability of finding the
Yeah,
electron,
with the
right?
help of these three, we can know the shape of the orbital also, like dumbbell shape or sphere shape, or what is the D shape called? I forgot that.
You can call it double dumbbell or clover leaf.
Double dumbbell. So we are getting with the help of these only. Okay. And the second one is what is the maximum probability? So if we are getting like spin quantum number plus half minus half, we'll learn all this thing.
Yes.
Okay, now this write one more line, important line. Next line. The reason in a space where the maximum probability of finding electrons, the reason in a space where maximum number of electron, maximum number of electron,
Yes.
probability, the reason where maximum number of electron probability is there, that is called atomic orbital. That is called atomic orbital. Now write it down. Principal quantum number. Principal quantum number. Principal
Yes.
quantum number. So principal quantum number is denoted by n, and it is basically the number of shell. We can say that how many number of shells are there. So like for the value like k, for the k shell is the first shell, no? So in that case, like k, then L, M, N,
And
and so on. So for that, the principal quantum number, which is denoted by small n, like k value will be 1. Then 2 for the L, 3 and 4. Like so, first shell is the k shell, k orbit, okay, k stationary shell, which is the first principal quantum number.
yes.
Okay,
So
and
K
what it
so basically K shell the number of the orbit the number of the orbit in K shell is one.
Yeah. Okay. Means the first shell after the nucleus is basically we used to say K shell, no? But in that principal quantum number, the value of K shell would be 1 because it's the first shell. Second shell is L, so we'll take L shell is 2. Are you
Yes.
getting this?
Because
Now,
L is
what is the.
and M is
Yes,
a
yes.
third shell, so we take it as 3. Then N is a fourth shell, we take it as 4.
4. Okay. Now, what it helps? It helps, like, why we are using this? It helps determining the size and energy of orbit of a orbital. So we know that the first shell is K shell. So the energy will be less as compared to L shell. So n, which is a principal quantum number, says us that the second principal quantum number will have more energy and the size will also be more. Are you getting this point?
Yes.
No. So it gives the information. Okay. Are you getting this?
Yes. Yes,
Okay.
sir.
So, and one more thing. If principal, okay, we can write this thing. Principal, I'm not writing full name, I'm writing only n. N is directly proportional to distance from nucleus. Distance of electron from nucleus, sorry. Distance of orbital, we can say. Distance of orbital from nucleus. Okay, this is one relation. Like if the principal quantum number will increase, then the distance of that orbital from the nucleus is gonna be more. For example, if I will write 3d5 or 4d5. Now the first number is denoted as the principal quantum number, then the 4 is 3. So this one will be far as compared to this one. Are you getting this? No.
Yes, sir.
Because the quantum number is more, then the distance of orbital from nucleus will be more. Did you understand? Say yes or no.
Yes, sir.
Okay.
Yes.
Understood?
Yes.
Now write it down next one. Azimuthal quantum number. Next one is azimuthal quantum number.
Yes, sir.
Azimuthal
Ajji. 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 Ajji.
quantum number. It is denoted by
L.
L. It is denoted by what? It is
L.
denoted by L. Okay. Now, azimuthal quantum number is basically the L, and it says basically the size. No, not size, shape. Sorry, shape of orbital. It usually says the shape of the orbital, and it depends upon the principal quantum. The principal quantum. And how it is depend? L is equals to n minus 1. L is equals to n minus 1. Now how it works? So it works basically if the n is equals to 1. N is equals to 1. In that case, there is only 0 or L. 0 L will be there. For example, if the value of n is equals to 1, then in this case, L will be n minus 1. So L will be 0. Got it?
Yes, sir.
So basically, it tells us about how many subshells are there. How many subshells are there? So if I will say that if n is equals to 1, okay, so there is only one subshell is there. There is only one, like for example, s orbital. S orbital has how many subshell? only one subshell in which the electrons are there. Are you getting this?
Yes,
If I
sir.
will talk about n is equals to 2, so in this case, how many L will be there? N minus 2. Sorry. 2 minus 2. 2 minus 1. So it will have the value 1. So now, what are the total values will be there? It will be minus 1, 0, and 1. Are you
So,
getting this?
so not minus one, zero,
No,
and
no,
one.
I'm mixing something.
Only zero and one. You're mixing
0
up.
and 1.
You're
Sorry,
mixing.
sorry, sorry. I'm mixing something. I'm mixing something. That is magnetic, no?
Yes.
Magnetic. Sorry. My bad. So it has two subshell then. Two subshell.
Yes, sir.
P has L value as 1. Then notation for subshell. Two subshell. So for the value of, like, this is the n, when s is equals to 1, sorry, n is equals to 1, then it is basically called as orbital. Which orbital? S orbital. In the value of s orbital, the L will be 0. In the value of p orbital, the n will be 2, but L will be 1.
Yes.
Okay, L will be 1. And in the case of d orbital, the n will be 3, but L will be 2.
Two.
Okay, and then in the case of f orbital, the n will be 4, but L will be 3, like n minus. Okay, write it down. Let's go.
Sir,
Yes.
actually, for see, for s orbital, I mean, basically, for n is equals to 1, you can have L value as only 0. That means they can only form 1. For n is equals to 1, there can only be an s orbital. But if n is equals to 2, L can have the value 0 and 1.
0 and 1. Yes.
Yeah, 0 and
S.
1.
Uh,
That means when n is equal to 2, both s orbital and p orbital can form.
mm,
And when n is equal to 3, the L value will be 0, comma 1, comma 2. So when n is equal to 3, s orbital, p orbital, and d orbital also can form. And when
yes.
n is equals to 4, the L value can have 0, 1, 2, and 3.
So,
So
so
form
means
S, P, D, or F.
so these things we can make. So when L is equal to 0, only like in the case of when orbital, when n value is 1, when principal quantum number is 1, then only s orbital we can use, like 1s2. We can't take 1p2, yeah, 1p3. We can't do like that because the n is equals to 1, then L will be 1. So only s orbital we can use in the case of when principal quantum number is 1. When principal quantum number is 2, in that case we can make s also and we can make p also.
Yes.
Got it?
Yes.
So do you heard about 2d7? It's not there. Why? 2p7. 2p7 is not exist.
Because in the p subshell there are only three
Only
orbitals.
uh,
And there are only three orbitals. There can
no,
only
even you will not hear about 2d5. We cannot make like this.
in 2D5 is not, but 3D5 is there.
3d5 is there. Why it's not there? Because the principal quantum number in that case is 2, and if the principal quantum number is 2, then L value will be 1. Means you can use only 0, which is the s orbital, and you can only use the p orbital in that. Other than that, you can't use.
Yes.
Understood what I'm trying to say?
Yes, sir.
Thanks for reminding. Now, right next line.
Wait, I'm doing it, sir. Done, sir.
Okay. Now write it down. Last line. It is. It is also. Sorry. Not it is. Like right. It determines. It determines angular momentum. It determines the angular momentum of an electron. It determines the angular momentum of electron, and it is also known as orbital angular momentum, and it is also known as orbital angular momentum. Orbital angular momentum. So if you want to find the angular momentum of electron in an orbital, then it is denoted by L into L plus 1 H upon 2 pi. This is a formula for it,
Yes.
where L is stands for azimuthal, quantum number, and H stands for Planck's constant. Okay? Did you listen, Edric? Say yes or no?
Yes.
Okay. Okay, then we'll end this class till here only, and then tomorrow we'll meet and we'll do the what?
Magnetic quantum
Uh,
number.
magnetic quantum number. Okay. So I hope you have
Sir,
enjoyed the class.
sir,
Yes.
tomorrow at